Hello guys, and welcome to another video. So in this video we'll be looking at part 1 of quantitative aspects of chemical change, and what we are talking about on this video covers both grade 10 and 11. So the first thing I want us to look at is the atomic mass and the mole concept. So we'll be looking at key definitions in terms of this section, and now we will start with our definition of the mole to say what exactly is the mole. And the mole, in simple terms, guys, is the SI unit for the amount of substance. All right, it's the SI unit for the amount of substance. And if we talk of the amount of substance, we are actually talking about what? The number of moles. And the number of moles are measured in what? In the SI unit, that is the mole. So the mole is pretty much the SI unit for the amount of substance. And we now see that 1 mole is defined as the amount of substance having the same number of particles as the R atoms in 12 grams of carbon 12. So we said we have the mole. The mole is what? The SI unit, and we have 1 mole, and 1 mole is pretty much what? The amount of substance which has the same number of particles as the R atoms in 12 grams of carbon 12. So those are the first parts of our definitions. Then we move on to the other definitions. This time we are looking at the definition that is relative atomic mass, which in brackets can be written as a lowercase a small r there. So the relative atomic mass, guys, is the mass of a particle on a scale where an atom of carbon 12 has a mass of 12, and this relative atomic mass will not have any units. Most of the time when we see mass, we think, oh, mass is measured in kilograms, but in terms of the relative atomic mass, this one will not have a unit, and it is pretty much the mass of a particle which is on a scale where an atom of carbon 12 has a mass of 12. All right, we move on now to another definition. The other definition that we have is Avogadro's number, and Avogadro's number can be denoted as Na. What is Avogadro's number? Avogadro's number is the number of particles, okay? The number of particles, and particles, and rather by particles we mean that we have atoms, molecules, or formula units. So when we talk of the Avogadro's number, we are saying it is the number of particles which are present in 1 mole of a substance. And Avogadro's number is actually a constant value, which means that this value was determined a long time ago, before we were born, I believe. And this is the number that they came up with to say that an Avogadro's number will be 6,02 times 10 to the power of 23 mole per dm cubed. But in simple terms, it is the number of particles which are found or are present in 1 mole of a substance. And if they ask you what are those particles, you will say those particles are atoms, molecules, or formula units. All right, let's have a look at our other definition, and this time we are looking at the molar mass. And what is the molar mass? As you can see, the molar mass is also denoted by this capital letter M. So the molar mass is pretty much the mass of 1 mole of a substance. It is the mass of 1 mole of a substance, and it is measured in grams per mole. Grams per mole in symbols is G dot mole, and then there we have -1 on top. So that is the unit, to measure molar mass, okay? The mass of 1 mole of a substance. All right, that is our other definition. Now we are moving on to the next section, and the next section now is to look at the relationships between our masses. Okay, firstly we have the relative molecular mass. Okay, we have the relative molecular mass. This one is used for covalent substances, or you can say molecules. And if you remember, if we talk of covalent substances, we're talking of bonds which are formed between non-metals. So when we talk of a relative molecular mass, we are talking of a situation whereby we'll be looking at the masses, or rather relative atomic masses, which are found within molecules, and these will be found from atoms which happen to be non-metals. Okay, so let's find out what the definition is. Firstly, we already know that when we see relative molecular mass, we are talking of masses which are used in terms of covalent substances. And the definition is that this is the sum of the relative atomic masses of the atoms in the molecule. Okay, and the molecules will be found in terms of what? Covalent substances. So that's what a relative molecular mass is. All right, then we move on to another definition. This time we are looking at the definition of relative formula mass. Okay, relative formula mass is used for ionic substances, or you can say ionic compounds. What do we mean, or rather what comes to mind when you talk of ionic substances? We're talking of substances which are formed due to the transfer of what? Electrons, and this happens between a metal and a non-metal. When we talk of covalent substances, we're talking of substances which are sharing electrons, and that sharing of electrons is taking place between non-metals, and that has to do with what? Relative molecular mass. But when we talk of relative formula mass, we are now talking of a situation whereby we have substances which happen to be a metal and a non-metal, and there's a transfer of electrons. Okay, and that means we form ionic compounds. So relative formula mass in simple terms is the sum of relative atomic masses of the ions in the formula unit. Okay, so when it comes to the covalent substances, we have a molecule. When it comes to relative formula, or rather when it comes to ionic substances, we have a formula unit. So those are the differences, guys. Okay, first of all, relative molecular mass is when you are looking for masses of substances which happen to be covalent, whereas relative formula mass is when you're looking for masses of substances which happen to be ionic. All right, I hope you understand those differences, and I hope you are also writing these definitions down, guys. In case one of them comes up, you do also need to memorize them, so I hope you are writing them somewhere as you are watching this video. Let's look at another type of mass. This time we are looking at molar mass, and we've already said that molar mass will be denoted by the capital letter M, and the difference is that molar mass has the exact same numerical value as the relative molecular or formula mass, but it includes the unit G, or rather let me just say grams per mole. Okay, that is the unit there, grams per mole. So those are the differences, guys. Okay, but I want you to also notice something, the difference between molecular mass and your relative formula mass and relative molecular mass. It's that the relative molecular mass and the relative formula mass will not have units. Okay, because these two masses, the relative molecular and the relative formula mass, come from what? They come from this one. They come from the relative atomic mass, and we know that it's not supposed to have units. Whereas when we talk of the molar mass, which is the mass of 1 mole of a substance, it will have a unit. So those are pretty much the differences. I hope, guys, that makes sense. Let's now move further. What we'll be doing now is actually calculating our molar mass, which is in a capital letter M in terms of a symbol. But I want you to know that you can also calculate the relative molecular mass and also the relative formula mass. You can calculate them. You calculate them the very same way we are going to calculate our molar mass. It's just that when you calculate the relative formula and the relative my English is slipping away. Okay, yeah, so when you calculate the relative molecular mass and the relative formula mass, we are gonna use the same procedure. It's just that we're not gonna give units. Let's have a look at how we calculate our molar mass. So here they are telling us, this is the instruction to say, to calculate the molar mass of a compound, use the relative atomic masses, AR, which are found on the periodic table, and multiply them by the number of each atom present. Okay, that's what I'm going to be showing you in terms of this video. And for you guys to make your life easy, I will need you to have your periodic table next to you as we are doing these calculations. Okay, so please do make sure that you go fetch your periodic table so that you can find ease in calculating these molar masses. All right, let's go. I will allow you to pause so that you get your periodic table next to you. All right, guys, I hope you now have your periodic tables. And before we do our calculations, I just want to make you or rather get you familiar with the periodic table. So our periodic table, guys, has 3 numbers, okay, in terms of an element. So an element is usually a symbol by means of a letter. Sometimes it's one letter, like you see here. This is H, that's hydrogen. And sometimes you'll have 2 letters where one is big and the other is small. Okay, so that would be our element. An example here is that Cu here is the symbol, and Cu is our element, which is the copper element. And then we have 3 numbers that are around this Cu, this 29, this 1,9, and 63,5. But there are 2 numbers I want us to look at. This one for now, let's not talk about, the one on your left. Let's focus on the one on top and the one at the bottom. The one on top is smaller than the one at the bottom. So when you want to find ease in looking for your relative atomic mass number, you must know that it's the bigger number out of the 2. Okay, we have 29, we have 63,5. And if you want to know which one is the relative atomic mass, the relative atomic mass will be the bigger number out of the 2, except in terms of hydrogen here. But another way to remember this is that the number at the bottom is your relative atomic mass. So if I ask you what is the relative atomic mass of lithium, you should say it's 7. The number at the bottom of your element or symbol, element symbol, is your relative atomic mass, and that's the number you will be using when calculating molar mass. All right, I hope, guys, you understand that. So as you are looking at your periodic table, just know that we are gonna be making use of the numbers at the bottom of our element symbol. All right, thank you. I hope you got that. Okay, here's our first example. Here we are gonna be looking for the molar mass of water, H2O. So when we do the calculation, we'll start by writing a capital letter M, and then inside the bracket we'll write H2O. This indicates that we are looking for the molar mass of water. This capital letter M stands for what? Molar mass. And when we calculate the molar mass, we look at the number of atoms for each element to say how many hydrogens do I have, how many oxygens do I have, and we multiply those number of atoms by the molar masses of those elements. So in this case, how many hydrogens do I have? I have 2. So I will say 2 multiplied by the molar mass of hydrogen, which is 1. Okay, and this I believe you can see from your periodic table. Plus, then we check the oxygen. How many oxygens do we have? And how are you going to know the number of oxygens you have? You will look at whether there's a number here or not. If there's no number, that means you have 1 oxygen. If there's a number, it means you have that number of oxygens. So here we see at the bottom of oxygen, there's no number. So that means we have 1 oxygen. So 1 oxygen will be multiplied by the molar mass of oxygen, which is 16. So here you can say you have 2 plus 16, but I normally just go straight to the answer. 2 times 1 plus 1 times 16, which would give me 18. So I'll write that. That's my answer, 18 grams per mole. So this is the answer you get for calculating the molar mass of water. That's how easy it is, guys. I hope it's making sense. Let's move on now to our other... Oh my word, what have I done? Okay, we are moving on to the next problem. Okay, the next problem, guys, is us looking for the molar mass of carbon dioxide. So the first thing we are going to do is to write the capital letter M. Then in brackets, we write the formula for carbon dioxide. Then we say equal to, and then we check how many carbon atoms do we have. We only have 1. So this one will be multiplied by the molar mass of carbon, which is, 12. And then we move on to the next atom, which is oxygen. We check how many oxygens do we have, and you can see that we have 2 oxygens. So we'll multiply those number of oxygens by the molar mass of oxygen, which is 16. Then we use our calculator here. This will give us 12 plus this one will give us 32. And if we say 12 plus 32, we get 44 grams per mole. So this is the molar mass of carbon dioxide. I hope, guys, that's making sense. Let's look at this last one. So this last one says we have to calculate the molar mass of calcium hydroxide, and the formula for calcium hydroxide is Ca in brackets OH close bracket, and then we have a 2 at the bottom. Now before I do the calculation, I want you to understand what this 2 means. This 2 means that everything in brackets is multiplied by 2. So if I have oxygen, that means I have 2 oxygens because of this bracket here. And there can be another instance whereby maybe I have a number here. I'm just making this up. So if I have a number in terms of what is inside the bracket, let's say I have 3 oxygens inside the bracket, I will multiply those 3 oxygens by 2. So if I say 2 multiplied by 3, I would get 6, and that would mean I have 6 oxygens. Okay, so that's what I want you to understand, to say that the number outside the bracket means that whatever that is inside the bracket is being multiplied by 2. Okay, let's find the molar mass for this one. We'll have M in brackets Ca close bracket OH 2. Okay, this is what we have. And when we calculate the molar mass of this one, we will say firstly we have Ca, calcium, right? We only have 1 calcium, so we'll multiply that 1 calcium by its molar mass, and the molar mass of calcium is I'm not sure, is it 40? Yes, I think it's 40. Let me just check on my periodic table. Yes, it is. It's 40 plus, now we have a 2 outside here, right? This 2 means we have how many oxygens? We have 2 oxygens. So I'll say 2 times O. That means I have 2 oxygens. So I'll say 2 multiplied by the molar mass of oxygen, relative atomic mass of oxygen rather, which is 16, plus how many hydrogens do I have? I have 2, because I'm saying 2 times H. So I'm going to say 2 in brackets, the number of, the relative atomic mass of hydrogen, which is 1. Then from here, the calculator will do the rest of the work for me. I'm going to say 1 times 40, which is 40, plus 2 times 16 will be 32, plus 2. And then from here, we do the math. Okay. So when you add these numbers together, guys, the answer that you get is going to be 74 grams per mole. And that's how you pretty much find your molar mass. All right, guys, this topic, guys, is quite broad, so there are other things that we'll be looking at in terms of the next video. Just to make sure you watch this one, and do like and subscribe and share with your friends, guys, what you learned from this video. I'll see you on the next one. Bye bye.